day 2. So today we're going to be talking about problems where we have non-independent components. And what I mean by here is that the outcomes are not set percentages. There is a finite number of outcomes, set percentages. We have a finite number of outcomes, and once an outcome is used, it may not be accessible again. We call this without replacement. So, for example, if I'm choosing, if we're doing a thing and I'm choosing students to share their work, right? Once I call, I can only call on however many students there are. So there's 16 students here. So if I was going to randomly call you, there's only 16 students to choose from. It's not out of 100. If I had 100 students, it'd be nice, but I don't. I only have 16 students. So I need to be able to use a numbering system to identify that when I pick a number, I need to know that this number represents Amy, this number represents Alexandra, this number represents Soraya. All right. Secondly, once I've picked one of the students, I may not be able to pick them again. So if you've already shared your homework, then you are not going to be called upon again. All right. So you've shared your homework. You're not going to be called again. So now I have to, if you show up again in terms of me picking numbers, I need to ignore that because you no longer can be selected. There are other instances where I can select the same person over and over again. And maybe it's like share one experience of your life. And so you share an experience. All right, you're done. We go on. Oh, you got chosen again. All right, you share another experience. Okay. Boom, go again. You got selected again. Share a third experience. And so every time you're called, and you can be called every time, or you can be called no times, none of the times, you're going to share an experience. With replacement is if you can be called upon over and over and over, which is rarely the case. Most of our cases in our simulations will be without replacement, that once you are chosen, you cannot be chosen again. So we call these, so we're going to focus on, our focus is on unique, I refer to these as unique components, where every component is unique to one individual without replacement. All right. If, and this is this doesn't happen very often, if there are 10 or less unique outcomes, use single digits. Okay, it might happen. So the only time you're going to ever want to use single digits is if, like, let's say there was only like 8 people in the class. All right, all we had was 8 people. All right, if there was only 8 people, then I'm just going to use single digits. because I want every person to be one number. If more than 10, but 100 or less, use double digits. And this is basically what's going to happen a lot of the class time, and especially the homework, double digits versus single digits. 101 through 1,000 outcomes use triple digits, but this is not happening on an AP exam. All right, you're never going to go to triple digits, but it's something that you can do. So if we had, for example, there we're talking about all of the students within the school. All right, well, if we have there's about 482 students or something like that, 482 students within the school. So every student in the school is going to get assigned one of the random numbers, but because there's 482, I can't use double digits because there's only 100 unique double digits. I got to go to triple digits. Assign each digit assign each unique component to a digit or double digit state which digit or digits are paired are ignored, unassigned. So if we only have 20 students, if we only have, 16 here, if we only have 16 students, I'm only going to assign 16 numbers to those 16 students, which means there's 84 numbers, and this kind of gets a little bit tough. There's 84 numbers that I'm going to have to ignore. So what happens a lot in these problems is that you don't want to write them down, you want to ignore. So we'll mark them down on the thing. We're going to ignore, we're going to ignore, we're going to ignore. Oh, there's one of their numbers. Ignore, ignore, and so forth. If cannot select twice without replacement, state ignore repeats. Okay. So the best thing to do here is to do an example. Okay, so we're going to go now to our notes. I'm actually not going to do this example. All right, this is review from day one. All right, I don't want to. I want to make sure that we have enough time to go over, so we're not going to do it. So this one's just 72%. Now it's a percentage. Notice it says percentage, so we use double digits. We do it the same thing as yesterday. There's no ignoring that happens in that problem. All right. We're going to go to the second example. All right. So suppose we have an AP Stats class that it consists of 15 boys and 12 girls. So this tells me this is unique. This is not a percentage problem. This is a unique problem. There are 15 boys. Now, I don't know the names of the boys, but there are 15 unique boys and 12 unique girls. Okay? And I were to randomly select 3 students from the class to speak at parents' night. So we have some type of parents' night that happens, and I'm going to select 3 students to come in and talk on behalf of AP Stats. How likely, what would we expect on average that all 3 students chosen were boys, right? So in other words, I do this and it's a boy, and it's a boy, and then the girls are upset, and the girls would come up to me and say, That's not fair. That you selected all boys, and I come back and I say, hey, I selected them randomly. All right. And it just so happened that the outcome was all boys. And the question that we have, okay, what was the chance of that happening? Is that unusual for me to have gotten all three boys if 15 of the boys, students were boys and 12 of the students were girls? So, what is my component here? What am I going to be doing? What am I selecting? What am I simulating first? The context of the problem. Not the outcome, but what am I doing? In the homework last night for those problems, like we were opening boxes. So what am I simulating here? Now it's a time for yeah.
Huh?
Yeah, go.
Choosing students to speak apparently.
Choosing a student. Yeah, because each individual is choosing student to speak. And the option here is, of course, boy or girl.
Are we choosing 3?
Yes, but the component is each individual one. So what are we doing each time? I'm going to choose one student, then I'm going to choose a second student. So what you just stated is 3 times. So the trial is I'm going to select 3 students. So I stop after 3. So that's what goes down there in the trial. All right, I'm going to select 3 students. Okay. My outcomes. All right, am I going to use single digits or double digits?
Single.
How many students do we have? How many components do we have? Sorry, how many outcomes could there be?
2.
No. How many unique outcomes?
27.
There's 27. So the outcome, so I'm going to use, I have to use double digits because there's 27 from a random number table, okay? Because there's 27 students I'm selecting from. All right. Now, we don't have any names attached to any person, so we're just going to label them as boys. Boy 1, boy 2, boy 3, for example, but it's a boy. And so I'm going to label the boys first. So what numbers are boys? What numbers will I assign to boys? This first part will feel just like the percentage part. So how many boys are there? 15. So what numbers go to boys?
15.
No, what numbers?
Is it 0, 1 through 15?
Perfect. 0, 1 through 15. Okay. What about my girls? What numbers am I going to assign to each of the girls?
12.
Well, that's how many numbers. But what numbers?
1 through 12.
I already used 1 through 15, 0, 1 through 15. Can't use the same number over.
27.
What did you say?
16 to 27.
16 to 27. I add the 12 to the 15, that ends me at 27. All right. Did we use all of the numbers?
You have to add zeros. 0.
No, we don't. No, we don't.
Wait, really? Why?
Because we have 15 numbers assigned to boys and 12 numbers assigned to girls. So this is where the new piece comes in. This is where the new part comes in. Because they're unique, I'm going to ignore 28 through 99, and 00. So if those numbers come up, those numbers do not represent anybody. I ignore them because I only have.
I have a question.
Yeah, what is that?
Okay, so if those numbers pop up, do we like stop or do we keep going?
So we cross them out and we keep going. We keep going. You'll see when I mark up. So you see how I did the numbers this time. It's not like this weird spacing part right there. And I didn't put that little table because we're going to mark them directly on there and you'll see how it helps. Now, can I choose the same boy or girl to speak? Can I select the same person twice?
No.
So we ignore repeats. So if the person already was chosen in that trial, this is what happens with every trial. I'll ignore that person if it comes up. Now, my response variable is categorical. All right, it is categorical. It is yes if all boys and no otherwise. So a yes would be because we're wanting to find about the chances of all boys. So we're going to record yeses for my response if they're all boys, and I'm going to do no otherwise. And I'm going to select 3 unique students. So I'm going to select 3 students. So I stop after finding 3 different students. Now, how many numbers am I actually utilizing? Again, how many numbers am I actually utilizing in my simulation?
27.
27. So the probability that any particular student is chosen in the first case is 1 out of 27. The chance that a boy is chosen is 15 out of 27, and so forth. So what we're going to do is we're going to go to the numbers and we're going to ignore. The response would have been quantitative if the question said how many boys. How many boys would we expect? If that was the question that said how many boys, then it would have been quantitative and we would record it the number of boys or the number of girls, for example. Okay, quantitative is, so in here we want to know, did it happen or did it not happen? That's categorical. If we want to know how many happened or how many we would expect to happen, that is categorical. All right, so each time I'm thinking of every one of these numbers in pairs of 2. So we're going to mark it up. So the first thing is we're on trial 1. All right. First number is what's my first?
0.
0. Up, ignore it. That's nobody. That's assigned to nobody. Next number.
82.
82. Ignore. Next number.
26.
26. That's one of our numbers. And that is a boy or a girl?
Girl.
That's a girl. Now, I already know my answer. For the trial, right? The answer will be no. It's not all 3 boys because I already selected a girl. However, for the purpose of the simulation, we're going to finish it out, okay? I already know the answer is going to be no because it can no longer be all boys, but I'm going to finish it out because I want your numbers to match mine. So even though you know the answer is no for that trial, and some people are like, well, why continue? If I already selected a girl, why continue? Because we want to it's just easier to do it that way for us, okay? So next one. Next number.
89.
All right, what do I do?
Ignore it.
Next.
53.
Okay,
You also ignore that too.
good. Hey, get back here. Next.
19.
And that's a
Girl.
good. Next. I'll continue here. 64, ignore. 50, ignore. 93, ignore. And then 03, which is a
Boy.
boy. and my trial is over. So this is trial 1. All right. This was trial 1. Trial 1 is now over. And I record my response is a no. Okay. Let's go into the next trial. So trial 2 now. Okay. My first one is
23.
And that's a
Girl.
I already know my answer is no, but we're going to go on it. The next one number is
20.
20. It's a girl. Ignore 90. My next one is
25.
and a girl. Well, I was looking at the chance that they were all boys. It turned out in this one, I got all girls. Wasn't what I was looking for, but happens. All right, third trial. Ignore 60. I have 15, which is a boy. I got 95. Ignore 33. Ignore 47. Ignore 64. Ignore 35. Ignore 08, which is a boy. 09, which is a boy. So my response is
Yes.
yes. All right, trial 4. Ignore 90. 19, which is a girl. 09, which is a boy. 37, 67, 07, which is a boy. So my response is
No.
no. 15, oh, I want to change my color here. Trial 5. 15, which is a boy. 38, 31. Now, for the purposes of this, I want to do something really quickly just to kind of see how you would react. Right? What happens if this was 15? All right. What happens if that is 15 right there? What would I do?
Ignore because we ignore it repeats.
Correct. I would ignore it. All right. So I would not count that if that was a 15 because I already selected person 15. I would ignore it. All right. I just wanted to show you an instance of that. But it's not 15, it's 13, which is a
Boy.
and 11, which is a
Boy
boy.
also.
And it ends. And so my response is a
Yes.
well, I'm done with my trials. All right. So the correct, so it's not X bar. So it with categorical, all right, we do not use X bar. Okay. With categorical, the correct notation, and this is a notation I'll use later on, it's P with a hat. If you don't write that notation, it's fine. It's not nothing that's make or break us for anything. It's the sample or simulation. It's sample with simulation. Sample proportion. Proportions are percentages. That's technically what we're doing. But if you again, if you don't write that and you just go directly to the next part, it's fine. What is my response? What is my outcomes? How many yeses did I get?
Two.
Out of
5.
5. So according to the simulation, I expect to have all three students selected to be boys about 40% of the time. Now, in order to do this, is this unusual? Is something that happens 40% of the time unusual?
No.
Yeah. Now, a couple of things. We only did this simulation 5 times. All right. Traditionally, in really doing these simulations, like if you're doing it by hand, we would do them like 20 times. But I feel that's like really overkill for us because I just want to know the process. So traditionally, we do this like 20 times. Um, and the theory is that if you have, remember, less than 5% or 5% or less, all right, so if out of 20, if you get at least one instance or 2 instances, for example, then we probably wouldn't consider that to be unusual. In the real world, we use computers to run these simulations for us, so we can program it to do this for us. And we have the simulation run thousands, if not millions of times. And so it'll calculate all of the possibilities, or all the outcomes and how many yeses and over how many nos or total trials checked. If that number falls below 5%, then we would consider it to be unusual. And we would say, you know what, that was an unusual part. On the AP exam, sometimes they'll just give you the results of the simulation, and they'll say a simulation was ran, and these were the 1,000 results of the simulation. And then from those results, we can determine if a specific outcome or not was unusual. So that's what you're doing. I have to update your homework handout so that I'm going to focus it. Like I said, I'm going to keep one of the problems the same, and then I'm going to add these problems. Tomorrow, we'll learn about one more type of problem, one more wrinkle to these, and it actually happens with the response variable. It's called a continuous count. That's what we will add in tomorrow's lesson. I'm going to update the homework handouts. Give me some time because I haven't had a break. I need to have some lunch. I will update that homework. Thank you for those 4 individuals who attended Stats tutoring. I got the feedback, and I know for some of you, I heard some of your feedback in regards to, you know, the tutoring session, that tutor specifically. Let me see.